While the best cuts go to restaurants, the trimmings are the real heroes of the hot dog world.
Hot dogs require a specific lean to fat ratio, usually 70-30 or 80-20. This assortment is carefully monitored to hit that mathematical target. Even a tiny chip of bone could ruin the high-speed emulsion machines later in the process.
These labels are crucial for traceability, ensuring that if a recall happens, every hot dog can be traced back to this specific moment.
This is least cost formulation. Hot dog recipes change daily based on market price. If beef is up, we shift to pork or poultry, provided the label allows it.
Everything looks correct on the manifests. How is the new loading system working out?
It's much more efficient, less risk of contamination.
Before the meat can become hot dogs, it must pass a second round of inspections.
What you see here is about to disappear forever. In the next room, physics and chemistry will take over to destroy the fiber of this meat completely.
Right now, this is just ground meat. The fat and the water inside the muscle want to separate. If we cooked it now, it would be a crumbly.
We added salt and water, not just for flavor, but to unwind the proteins. The salt makes the meat sticky.
The blades slice through the now thickening batter. The texture has completely changed. It is no longer ground meat. This bind is critical. If it slides off too easily, the hot dog will be mushy. If it's too tough, it'll be rubbery.
This is the point of no return. We are creating a meat matrix. The fat particles are being
This quality control step ensures that you never bite into a hard piece of gristle in a finished hot dog. Air is the enemy. If we leave air in there, the hot dog will oxidize and turn gray from the inside out. Plus, nobody wants a hollow hot dog.
Too hot and the fat renders out. Too cold and it won't pump. This is the Goldilocks zone.
We have the meat, we have the chemistry, now we need the shape.
In the old days, we used sheep or hog intestines, but nature is inconsistent. Today, we use cellulose. Links per minute. That's more than 10 hot dogs every single second. If this machine creates a link that is 1 millimeter too short,
A macro shot follows a single black mark printed on the casing. This is a small, opaque. If the package is 15.9 ounces, it's illegal. If it's 16.5, the factory loses money.
right now this is just raw meat paste in a plastic jacket. If you bit into this, it would be a gross, wet paste.
This is the alchemy chamber. In the next 90 minutes, we are going to force a chemical reaction called protein coagulation.
This step is crucial. The casing must be tacky and dry to accept the smoke color. If it's wet, the smoke will streak.
It's not just turning on a stove. This is a step program. If we heat the fat, melts and breaks the emulsion.
Step 2, the smoke shower. A fine, dense, minced.
Why are hot dogs red? It's not dye, it's chemistry. The smoke is acidic. When it hits the meat surface, it cures the outside layer, locking in that color.
Pasteurization. This is the most critical safety moment in the entire factory. We have to ensure that every single particle of meat.
The protein strands, which were unwound by the salt, now begin to cross-link and bond tightly together under the heat. Step 4, the cold shower. The cooking is done, but the heat must be stopped instantly.
Perfect. The protein is set. The smoke is locked in. But they are still wearing their winter coats. We can't eat the plastic.
They are cooked, they are safe, and they are delicious. To set them free, we have to get naked. Nobody wants to eat paper. We have to strip them naked without leaving a scratch. And we're gonna do it at a speed of 500 feet per minute. This is the air knife principle. We don't pull the skin off, we blow it off. Right after the blade makes a cut, a jet of compressed air shoots directly into that slit. Smooth, this is what you know. No snap, just soft, uniform meat. This is what we threw away. The casing did its job.
If the blade is dull, it tears the meat. If it's too deep, it ruins the hot dog. It has to be perfect every time.
This bounce test is a visual confirmation of the texture. If they were mushy, they would splat. If they were too hard, they would thud.
They are cooked, they are peeled, they are naked. Now we have to dress them plastic one last time. This camera takes 5 photos of every hot dog in a fraction of a second. It measures length, width, curvature, and color.
The robot never tires, never sneezes, and never misses.
The age-old question, why 10 hot dogs and 8 buns? Efficiency. These machines are designed to run specific patterns. A standard pack is 1 pound.
The lid clamps down. The plastic film suddenly sucks tight as the air is violently extracted. This is
This code is a time machine. They can tell you the temperature of the smokehouse. Every second of this hot dog's life is recorded on a server. It's not just food, it's data.
Careful on the seals today. I just tossed one.
Yeah, I saw that. They're going fast, though.
This is the unit of commerce. Not the hot dog, not the box, but the pallet.
The cold chain can never be broken. From the moment that animal died, the meat has been kept cold.
There they are.
You found them. Good job.